Welcome back to the series on how to use FreeCAD. In this video, we want to talk about constraints, different kinds of constraints. In the previous video, we talked about different tools under like the SketchUp workbench. And those tools that we talked about are the ones that help us to draw different shapes. Now we want to talk about different tools that help us to constrain those shapes. So I'm going to delete all of these objects. I'm just going to highlight all of them and delete them. Now what I want to show you is what constraints are for. So let's start from the point tool again. So point, and then I click on the point I want. I want a single point only. So I just click on escape or press escape on my keyboard. Now you can see here it says under constrained and it says 2 degrees of freedom. So it's showing me 2 degrees of freedom. I need to do something to make sure that it is fully constrained, and you will see what that looks like in a minute. What fully constrained means is that I will not just be able to move this point around. Like the computer solver, the solver of FreeCAD will know where this point will be at any point in time. So FreeCAD is a parametric software, and a parametric software is a software that runs on parameters. So it needs parameters to be able to know what this point is and where it is. So now if I want to tell FreeCAD that this point is at this space, right now we don't know where this point is. The computer does not know where it is. It only has like a picture of where it is. So let me tell it where this point actually is. I will use the constraints. So these are like my constraints. From the dimension up to here, they are my constraints. So let's take them one at a time. So if I ask for the dimension tool now, I can click on this point. You can see it automatically just links me to the center point. So I've clicked on this point already. Then I'll click on this center point, and then I'll just drag straight up, straight. If I do this, that can work too, but I'm not going to do that. I just want to drag straight up. So I'm going to give that a height or a length of 60 millimeters, and then you can see that it changes to 1 degree of freedom. So that, let me press escape to remove the dimension tool. That means that I can't move this up and down again. It has been constrained in that direction, so I can only move it to the side. Now that's the only degree of freedom I have. So now to stop that from moving also, I will add a dimension to it. So I'll just click on this and click on the origin point there, and then I'm going to have a constraint of 60 millimeters. So you can see that that point is now green, fully constrained, and that is beautiful. You have no idea how beautiful fully constrained is until you have a very complicated sketch that just needs one more constraint to be constrained. So fully constrained, and it's green. So that means that I can't move this point around again. Like every point on my sketch is now fully defined, and that is what you want to aim for. Every sketch should be fully constrained. I want to show you something. So if I delete this dimension here, it is 1 degree of freedom. If I close this, you will notice that it is putting an X on my sketch. The reason that X is there, I think it's because it is not fully constrained. So if I click on the sketch and I attempt to make it fully constrained by adding dimension tool and then clicking on this to make it 60 millimeters, so it says fully constrained. If I click on close now, although I cannot see the point, but you can see that my sketch does not have that X symbol again. So it has been fully constrained. Now I'm going to delete all of this. Delete. Let me draw a rectangle. So this is the rectangle tool, and then I am going to show you something. Before I do a rectangle tool, let me press escape. I want to show you something under this place. By default it is usually selected, but in case it is not selected, it is very helpful sometimes. So if you come to beside this this symbol for a screwdriver settings and click on this drop down, you will see auto constraints. I want to make sure that it is checked, and then avoid redundant constraints too, or auto remove redundant constraints also needs to be checked. Now if I click on my rectangle tool and I click and I draw my mouse, I want you to notice very well the things that are following my mouse around. You see that there is a coordinate system and a rectangle tool like thing following my mouse around. If I click escape, all that goes away. If I click point, you can see that it is the point that is following my cursor around. So be careful about the things following your cursor around. It must be the tool that you want to use. Oh, I just escaped the sketch by mistake. Okay, so if I click on my rectangle tool now, my rectangle is following my sketch around. But I want you to notice something. If I bring it close to this line, that is the I believe the y-axis. If I bring it close to the y-axis, you can see that another sign shows up. Another sign shows up, and we'll talk about that in a minute. If I bring it close to the y-axis, another sign shows up following my cursor. If I bring it close to the origin, another sign shows up. So let's talk about those one at a time. But before I talk about them, let me just create a rectangle, and then I will constrain the rectangle manually. Then I will do an automatic constraint too for it, so that you can understand the difference. So I'm just going to create a rectangle, and you already know by now that a dimension is a constraint. So I'm going to dimension this rectangle, make this 30, and then make this other length to 30 millimeters. So that already constrains my rectangle in two ways. Now, what I want to do is that I want this point and this point to be coincident. That means I want them to be at the same point. So I'm going to click on this point, and I'm going to hit my command. For me it's command, for you it may be control on your Windows or your Mac. So for me it's command on my Mac. So I'm going to click on this and then control or command this other point. That's to select both of them, and I'm going to come to this constraint. It is called the coincident constraint. So once I click it, it brings that point to this same point here. That is the coincident constraint. That is the coincident constraint. So that makes my sketch to be fully constrained, because I already told it where this point is, and I already gave it the dimensions that it needs. That is my manual dimensioning and constraining of this rectangle. Now let me create another rectangle. So let me make this 20 by 20. Now there is something that I can do. I can make 2 points or 2 lines to be collinear. So you see this, like I can make them to be on the same line. So I can constrain them horizontally or vertically. Let me display that, or let me explain that using a line. So if I click on this line here, and I click on here, and I just click any other place for the second point of the line, let me click escape to escape the tool. If I want this line to be vertical, like straight like this, I only need to click on this line and then click on this drop down and click on constraint vertical. So that brings it to the vertical direction. Let's say I don't want it to be vertical again, or for any other constraint I don't want the constraint again. You can see the constraint symbol is beside it here. So I can click on this constraint symbol and delete it. So that makes me able to do anything I want to do again with it. If I click on vertical and click on this line, so it's vertical now, I cannot do anything. It will always be vertical. It will always be vertical until maybe I delete this constraint, for instance, and then I can do anything I want with it. So if I want to make it horizontal, I'll just click on it like this, click on this drop down, constraint horizontal. Oh, hope my device does not die before we end this video. Okay, so you can see that it will remain horizontal. So now what I want to do is that I want to bring this point to a point that is horizontal with this other point here. So I'm going to click on this, then control or command this, and I'm going to click on this drop down and then constrain vertical. You can see that. Now if I want to bring this point again to a place that is horizontal with this, I'll just click on this and then click on this, so it will bring it to the same line here. So I'll just click on constrain horizontal, and that constrains it horizontally for me. I hope that it is clear. That is to talk about this horizontal and vertical constraint. Now let's talk about the next the next one. If I have a line like this and I want this line to be parallel to another line, so let's say I have another line that I have drawn on my rectangle here, and let's say I just have it something like this. For the sake of drawing, let me just draw a point like this. So let's say we have something like this. You can see that it has auto constrained it as a vertical line, and let me show you how that happens. So let me delete this line and let me click on the line tool again. So if I click on this point, right, and I'm bringing it up, you can see that nothing is showing beside my mouse. But once I try to make it like straight, you can see that straight symbol that it brings. It's gone, it's back. That straight symbol means that once I click on it, it will constrain it. You can see the other symbol too that appeared. That symbol means coincidence. So it is telling me that it will be coincident with that point that I am taking it to, and it will also be like vertical. So if I click on that, it becomes vertical and coincident. So let's say I dimension this angle to be say 30 degrees. Okay, so to dimension an angle, you just click on the lines that are involved to be 30 degrees, and I want this line to be parallel to this 30 degrees. So what I will just do is to click on this and click on like shift or control this, and then I'll just click on parallel constraints, and that makes sure that both of them will be parallel. Nothing I do, even if I shift it and change it, it will always be parallel. It will always be parallel. That's just it. So that's the parallel constraint. Now what if, as I have this parallel, right, I need another line. Let me create another line, maybe to this like this, maybe at an angle to it like this. So you can notice that this is coincident, like it is passing on top of the line. This is the coincident constraint here. So if I want this line to be perpendicular to this line, all I need to do is to just select both lines and then click on this perpendicular constraint. So it makes it perpendicular. Everything I do, it will remain perpendicular to each other. Even if it goes out of the line, it will remain perpendicular to each other. So you can see that is the perpendicular constraint. Now for this tangent constraint is very useful when you have a circle, an arc, or things like that. So let me show you. Let me create a circle. So let me just draw any circle here, and then I want this circle to be that it will be at a tangent to both this line and this line here. So what I do is to click on this circle and click on this line and apply the tangent constraint. You can see that. Then if I want it to be tangent to this as well, I click on this. So you know what tangent means, right? So tangent is like it will always be at that tangent, like it will always be at, it will not enter that circle, it will always be at like 90 degrees there. It will only be touching the edge. So if I want it to be tangent to this line as well, so I just click on the line, click on the circle, like select both of them, and then click on that tangent tool. So you can see that the line is not even there, but if I extend that line, right, you would notice that it will always be at a tangent to that circle. It will always be at a tangent to that circle. So that will be very helpful later on, as we'll be picking up tutorial exercises to do. So that's the tangent constraints. Now equal constraints. So let's assume that I have another circle. It could be a line, it could be anything. If I have another circle here like this, if I want both of these circles to be the same radius or the same diameter, I can just click this, like select both circles and click the equal constraint. So that means that as the dimension of this first circle changes, the dimension of the second circle too will be changing. That's what the equal constraint does. One will always be equal to the other, very simply. Now let's talk about the symmetric constraint. So look at this, for instance, this line that I have. So imagine that I want this point to always be at the center of these 2 points here. That's where the symmetric constraint comes in. So I click on this symmetric constraint, and then I click on the first, I click on the second, and then I click on the one that I want it to be symmetric to. And then you see that this line will always be at the center of those 2 points. It will always be at the center of those 2. You can see that the line is no more moving relative to those 2 points. It will always be at the center. It will always be symmetrical to those 2 points. And you can see that my circles that I've made equal are still changing in size. That's what constraints are used for. They are helpful for locking things down in order. And then we have this constraint, like it just blocks the selected edge from moving, like it will not move. So basically, if I click this and I click that constraint, this circle will not move anymore. Now let me see. This can still move, but the size will not change because I have made this circle equal to this circle, and this one is blocked. So the block constraint is like a last resort constraint, just to block the thing from moving, or the shape from moving or doing anything. So let me show you a quick way to use constraints now. I'm going to highlight all of this and I'm going to delete it. So let's say I want to set up a very simple object. So let's say a rectangle of size, say 80 by 80 millimeters. Now if this is 80 by 80 millimeters and I want a line, like I want a line to divide this into 2 equal parts, for instance, so I can just click on this line 2 here. I want to show you a very easy thing to do. So if I want to get the center of this line, for instance, if I hover my mouse over this line, you can see that symbol, that symmetry symbol show up. It means that if I click it, it will put me at the center, the exact center of that line. And if I'm moving straight, you would notice that that symbol for vertical, or is that horizontal constraint, will show up. And if I click on this, that brings me to exactly the center of the line. So you can see that it's fully constrained still. Very simple. And then I cannot move this because it is just at the center of that line. Now if I want to put a point at the center of this line still, I can just do this by clicking on this point and then bringing this point close to the center here. You see that symmetric constraint shows up and I click it. So that point will be at the center of that line. Now the thing is that I don't want this line to be a rigid line, because the thing about FreeCAD is that your object must be continuous. So for instance, if I want to extrude this object, because of this line in the middle, I will not be able to extrude this object. So I want this to be a construction line. So how do I make it a construction line? So I click on it and I click on this here. So it turns it to a construction geometry. So you can see that that line is now thinner and is blue. So I want to put a circle at that point here. So just a circle, and then I'm going to make that circle maybe 50 millimeters. And that gives me a good object. So I close that and I have my sketch here. So this is my sketch, and I can extrude that object now using the pad tool, which we'll cover in the next video. So using the pad tool, and then that gives me a very beautiful block over there. So in this video we have covered the sketch tool. We have covered the importance of constraints in the sketch tool. In the previous video we covered how to use different shape tools. In the next video, before we move on to solid operations, we will try to sketch different complex objects, simple objects, so that we can just get a hang of how the Sketcher workbench operates. Thank you very much for joining me on this video. I will see you in the next video. Please don't forget to like this video, share it with your friends if they are doing engineering too, or if they are just hobbyists and they would like to get in with it. Subscribe to our channel so that we can reach more people. Thank you for watching. I will see you in the next video. Bye.